So now that we've actually got an idea as to what the change in traffic volume is going to be, with our site, without our site over here in future background in 5 years' time, what our site's going to do in site traffic, and then in 5 years' time with our site, the future total. Now we've got to get some idea as to how we actually judge the impact of these things, and that's where some of these computer packages come into use. So there are literally thousands of these things out. Well, maybe not thousands. There's a lot of traffic analysis software out there. Here's an example called Intercalc, which is from ITE. So that's the Institute of Transportation Engineers. It's using the CCG, which is the Canadian Capacity Guide. Again, as I mentioned in the very first video, it's very important to know what are the local requirements because they're all slightly different based on exactly where you're doing this report and the level of detail that they want. And obviously this report is in Canada and they would like you to use the manual called the Canadian Capacity Guide. Whereas if you're in the US, you're going to have to use the HCM, the Highway Capacity Manual. If you're here in Australia, you're probably going to have to use the local Australian one, which, to be honest, off the top of my head, I do not know, because I haven't done very many traffic impact analyses in Australia. And when I do, I look it up every time to make sure that I'm doing the right thing. Here's another example. This is a program called Synchro. But it is using the HCM capacity analysis technique. So Synchro itself has its own way of doing traffic calculations, but in this case it's doing the calculations as per the HCM manual. Again, slightly different methodologies, but fundamentally you're always coming out with some sort of answer at the end which says what is the level of service, A, B, C, D, E, F, F being bad of course. And there should be a volume to capacity ratio, so the volume is X, the capacity is Y, X divided by Y gives you a V over C, volume to capacity ratio. If you get over 1, that's bad because your volume is higher than your capacity. In some jurisdictions, again, you need to be careful and know where you are and what the context is. In some jurisdictions, particularly in suburban areas where they're used to being able to drive very fast all the way through the suburbs very quickly without much delay at all, having a V over C, volume to capacity ratio over, say, 0.75 or 0.8 is fundamentally unacceptable. But in busy urban situations where it's already very close to capacity, well, 0.99 is acceptable, whereas 1.0 is not. There are various other bits and pieces that are pumped out by this piece of software. There should be a delay. Here we go. There's a 95th percentile queue length, which is sometimes important. So trying to decide how long your turning lanes need to be. 95th percentile queue length is 2.2 meters. So we clearly don't have a problem here with queues. That's less than a car. So 95th percentile is often used as a good idea of, well, 95% of the time it's going to be less than this number, but 5% of the time, 1 day in 20, 1 hour in 20, whatever, it might be a bit longer for a short period of time, and that'll be acceptable because we can't build for the 100% thing because it all tapers off to infinity and we'd end up with ginormous traffic lanes and turning lane lengths which just don't make any sense economically. Even designing for the 95th percentile doesn't make a huge amount of sense. And if you want an example, think about a very, very large shopping centre. Think of Chadstone if you're familiar with Melbourne, with a lot of parking. Somewhere in Chadstone, there's probably a parking space that gets used maybe once a month, once every 2 months, because it's the last parking space. It's the one that, the full wants that parking space, and not necessarily that particular one, but there'll be some period of time where Chadstone will be full, but it won't be very often because we've designed it for the 95th percentile, which means that essentially we're having to build a lot of parking spaces that don't actually get used all that often. They might get used, the busiest Saturday before Christmas might be one of the few times when the parking spaces in Chadstone are full. but that parking space still costs, that very last one, still costs us $40,000 to build. Along with all the other ones, they cost us about $40,000 to build, or it'll cost us about $40,000 to build another one. Anyway, I digress again. Back to some of the computer packages. So we talked a bit about Synchro. Here's a local version called Sidra. You can jump online, have a look at their website. One of the things that I definitely picked up, and you'd notice, is this is the list of references that they have for their roundabout component. And you can see that there has been an inordinate amount of research into this piece of software, refining it, making sure that it does exactly what it's supposed to do, that it accurately models traffic conditions, and that there's enough buttons and levers and things to press that you can get it to, accurately reflect how people do. Here we go. Evaluating roundabout capacity level and service, the relationship between capacity and driver behavior. So this piece of software is trying to account for the way that different drivers behave, and you can get some idea as to why various jurisdictions would like you to have, one set of settings versus another set of settings. Because if you're in the US, for example, where they don't have very many roundabouts, you might expect that the roundabouts would have a lower capacity because people are a bit more cautious. Whereas here in Australia, where we're quite familiar with roundabouts, we can go through them quite quickly because we know how they work, and so we're a little bit more aggressive, and so we get a little bit more capacity. And so these things can make an effect on how this sort of stuff works in the computer. Here's a few more examples. Aim sum. I know that we use that at Monash a fair bit. I'm not a modeler, so not really my area. But, you can talk to various PhD students and other staff members who use this sort of stuff all the time. I've had some exposure to Vism, which has various bits and pieces. There's Vistro, VisWalk, which is for modeling walking, obviously, all sorts of stuff. VisSum, I think, is quite useful because that does quite a bit of the adding and subtracting to get your traffic volumes. It does it internally within their own system, and so it's much easier to move things around. You don't have to spend as much time in Excel. But fundamentally, Vism is a micro simulator model, so a slightly different approach to things like Synchro, where they're actually hand calculating V over Cs using many of the principles that you would have touched on the second year subject on traffic engineering, so signal timing and some of the mathematical relationships that allow you to work to figure out what the capacity is. Whereas Vism is instead a micro simulator that's actually putting out agents into a virtual version of the traffic system, and therefore figuring out, based on a number of runs of this micro simulation model, what might be likely to happen. So you might find in traffic engineering practice that you might do a lot of this sort of Mezio models, I believe they're called, where it's sort of a bit more calculation, or it's based on throughputs and volumes. Or you might be doing, this sort of micro simulation where there's actual, micro simulated models, and the computer's really churning it over and modeling each individual vehicle and how it behaves. I've done bits and pieces of both. Had to do micro simulations of how parking garages would operate, but at the same time, for the same site, doing more macro scale type things for how the traffic signals would work. So anyway, there's a lot of software out there. I've only just briefly touched on a few of them, and that'll give you a bit of an idea as to where to start. But yeah, you can definitely become a specialist in one of these things, to the extent that at my previous job in Toronto, I don't know how to use Vism. I've never learnt. I can use Synchro a bit, but there was a guy who I worked with who was very good on Vism, and basically I just needed to know enough about how it worked to be able to talk to him about how I wanted the model to change, and then he'd get in there and do all the calculations and the coding and all this sort of stuff. And that sort of was the way it worked, because there was no point me learning Vism because he was already a Vism expert. And if you want to become a VISM expert or an expert in any of those sorts of things, there are a lot of roles out there because this is highly technical specialist type stuff. And it's always odd in my mind that we're back in here doing future background, site traffic, and future total and things like that, which is a bit more sort of qualitative. It's a little harder to, a lot of it's based on engineering judgment because you can't fully, you'll never know what the future total traffic volumes after you build the site will be until you actually build the site. And even then, if you went out there tomorrow and the day after, it would be different because every day is different. So there's not a huge level of precision in here, but then you get into these micro simulations and these calculations, and it's very precise. And so you've got to sometimes take some of the numbers that you get out of these with, a little bit of caution, because you have to remember that you are putting in numbers that have some wiggle room. And so quite often in a lot of these things, we actually adopt a conservative approach so that we know that we're going to be above. And so therefore, if we can prove that it fits on the road network, being conservative, well then, it'll fit on the road network if it's a bit smaller. If the new development, if we could put 500 units on and it would still fit on the road network reasonably, well, when you decide to put on 200 units, well, that's going to be fine too. So that's one approach to doing this sort of stuff, from a more conservative approach. But